So, welcome back. In this video, we will talk about Python packages, a way to organize our projects, and also a way to make sure that all modules within our projects are uniquely identified and cannot be mixed up with either Python's own modules or with other projects' modules. So let's have a look at the problem itself first. Okay, let's assume we have our lin solver project where we are programming our linear solver for linear systems of equations as we did in this course. And then we want to import an IO module. Actually, we want to import our IO module, which means the IO module which contains the input-output functionality of our project. But if you just write import IO, actually, which IO module should be imported? It could be, we could mean with that the project's IO module. We could mean by that but Python's IO module, because Python itself has an IO module, but it could be also just some other project's IO module which we wanted to import and reuse here. And it's especially very critical if there are many Python projects in our systems, as we have, for example, in Conda, because then the module names might collide, and then we would have to put modules of the same name into the same location, and of course that doesn't work. The solution to this problem are the so-called Python packages. Packaging in that sense means it's not installable packages, but Python packages, it's a kind of namespace. So basically we are uniquely identifying our project with a certain prefix, and then whenever we want to access modules with our project, we are just identifying it with that prefix dot the module name. So basically here, if we use this Python packaging scheme or package scheme, then we have the package name dot module name. So basically, and since the package name should be unique, then if the package name is unique, then the module name can be arbitrary, because each module is referred as package name dot the name of the module. So for example, if you're talking about the lin solver project, then we can write, instead of import IO, we can write linsolver.io. That means we are using the IO module of the lin solver package. And then it's clear that we were not meaning any other IO module. Actually, if you think about it, we have used that already without naming it. For example, we were using the numpy.linalg module. That means give us the linalg module from the numpy project. So it's basically here again, it's a package, the numpy package dot linalg, the linalg module within the numpy package. So how can we do that? How can we define such packages? And that actually turns out super easy, because those packages are nothing else, just simple directories in the file system. So let's assume we have our lin solver project, and within our lin solver project, we are creating a lin solver directory. So this is within our project, and now we are putting our sources, all of them, into the lin solver subdirectory of our project. So we will just put our io.py, which contains the input-output functionality. We are just putting solvers.py into that, which contains the solver functionality, and we will create an empty file __init__.py. This latter one is since the Python 3.3, if I remember correctly, it's not necessary, not mandatory, but I think it's a good practice to add it, because that tells Python, okay, this lin solver folder here within our project is meant to be a package directory, right? Okay, now if we have this one, then from that point on, we can use the package prefixes. So basically, instead of importing solver, we can say, okay, import lin solver.solvers. So basically take the solvers module from the lin solver subdirectory within our project. Similarly, if we want to here import the IO module, we can say, okay, import linsolver.io, and it will give us the IO module within the lin solver subdirectory of our project. Of course, when they are imported under that name, then you have to use exactly that name in order to access functionality within those modules. So if you want to call the read input from the linsolver.io module, then you have to say linsolver.io read input. The same with the solvers, right? So basically, this is all. And if you know that, you can already create packages. However, this is a little bit uncomfortable, especially if you are using various functionality from a package, because you have to import all the submodules, all the modules within this package one by one in order to access the functionality in the different modules. And this is exactly where the init.py file can come handy. Why? So what we would like to achieve here is to import just the linsolver package, and being able to access afterwards linsolver.io.readInput and linsolver.solvers.readInput. So basically we would like to just import the package and be able to access the functionality within various modules of this package directly without having to import them, all of them, one by one. And it turns out this is also super easy in Python, because you can use the init.py function, which was empty so far. But actually this file has a role. If this file is there and has some content, then this file is read, is imported, and basically the code in it is executed when the package linsolver is imported. So basically if we are writing import linsolver somewhere, then what Python does is just it looks up what is in the init.py file, and that code is executed. Now in this file we could do the following. We could say within this file import the linsolver.solvers module and just store it under the name solvers, and also import the linsolver.io module and store it under the name of io. And whatever names you create here and here, that will be names within the linsolver namespace, right? So basically if you do that and you are importing linsolver, and then the init.py had this content here, then you would immediately have access to the modules or this functionality, these modules in the package, right? So it's super convenient, and it makes, of course, for the users of your module and also for yourself much easier to use the content of your package. So you are only importing the package itself, and then within the init.py you make sure that the submodules of your package or the modules within your package are imported with the correct names, and then here after importing the package, basically you can directly use them. There's also an abbreviation here. You don't have to write the package name again and again. Instead of that, you can use the dot, and just the dot notation. Dot means okay, from dot, which means from the actual directory, import the module solvers. From the actual directory, import the module io. That would have exactly the same equivalent effect as the code above, but it's much shorter and more, yeah, it's easier to write and easier to read. Now we have hidden, or basically we made it comfortable to the user of our package to use the to the modules in our project. But actually the big question is, does it even make sense to use those modules at all? For us, as a developer of the packages, for sure it is, because those modules help us to partition our project into logical modules. But if our project has only a few functions, then probably it's an overkill that the consumers, that the user of our package has to remember that, oh yes, the read.input method was in the io module, the solver module was, the solve function was in the solver module, especially if each of the modules is only exporting one or two public functions. So it would be much nicer if the user of our package could just say import linsolver, importing our package, and immediately use the read input and the solve functions as if they were defined in the linsolver module and not in just in submodules of the package. And actually even that can be very easily achieved if you are using the init.py routine again. And here we are just again importing from the .solvers module. That means the solvers module within the current directory, which means current directory is a directory in which the init.py is located. Import just from the solvers module, import just the function solve. And from the io module in the same directory where init.py is located, just import the function read input. Both of these imported names will be in the namespace linsolver. So basically, if I'm just using linsolver and dot, I can directly access .name. So you will see I have here now just linsolver.read input and again also downstairs linsolver.solvers. solve. And this is super cool because I can hide the internal structure of my package. If I just make up my mind later during development and I would put the solve module or not in the solvers module than in some other modules because it makes more sense for the internal structure of my project, it doesn't really matter because the users are not using it from the concrete modules but from the package, and I can just always adapt init.py and hide the changes for the users, so whoever is using my library, my Python module, would be able to use it without changing the code. So that's quite cool. We can now hide the internal structure of our packages, how is it split up into various modules, but we should make even more hiding also further details, and we should even hide the different things which we were writing into this module. Why? So let's have a look at the solvers, solvers.py. Basically, the main routine of the solvers.py module is the solve routine, which basically implements the the linear system of equations solver, right? Within this solve module, however, because our algorithm may be longer, we just split up the functionality of our solver in various internal steps. These steps are not really important to the outer world because we only want people to call our solve routine, and we don't want to let them know how we split up the functionality of our solve function into some internal functions, whether we are just calling it eliminate or somewhere else or something else, or the substitute back or something else. It should not really matter, right? Also here we have, for example, here a tolerance value which we use internally in order to make sure if or in order to check whether our system of equation is dependent or linearly dependent or not. And again, this is something which we don't really want people to read out or try to manipulate. So how can so basically I would like to make this solve public, and then this routine here, and this constant here, I would like to make in a way of private or hidden. And as you already see here, basically you can immediately recognize what is the convention in Python. Basically everything which starts with an underscore in its name, it's considered to be a hidden routine, a private routine, and everything which starts with the normal letters, so from A to Z, it's considered to be a public routine. Please keep in mind that this is just a convention. So basically here, again, the convention is starting with a letter, it's public, starting with an underscore, it's private. Again, I would like to emphasize here that this is just a convention in Python, and actually there is a way in order to access those entities from the outside. However, this is something you should not do. So basically when you have a private entity, it should be only accessed from within the scope where it is defined. That means either from that module, or if later you are doing object-oriented programming, then you should only access it from the object instance itself where it is defined. Again, this is only a convention, and theoretically you can access those private entities from outside, but please make sure that you are keeping to this public-private naming convention and also programming convention, because basically all Python projects do so, and you should make sure that your project is not causing big surprises to other developers when they are joining it.